So in this video, I'm going to talk about solution concepts, how to solve games. So first we'll look at dominance solvability. And we're going to focus first on strict dominance. So let me write down the definition of strict dominance. So for player I, so UI, the expected payoff for player I, which is UI, by playing strategy sigma I, which could be either a mixed strategy or a pure strategy, given the rival's strategy. If it's strictly greater than the expected payoff for player I from playing his strategy SI, given the rival's strategy S subscript minus I for all S minus I belonging to S minus I. So basically what we are saying here is that player I, if he plays his strategy sigma I, which could be a mixed strategy or it could be a pure strategy, given the rival strategy, S minus I, so other players' strategy, whatever they play, right? So if the payoff, expected payoff, UI, is strictly greater than if player I were to play some strategy SI, given the rival strategy S minus I, for all S minus I. So let's try to solve, we're going to look at basically what is a dominant strategy. So we won't go into the solution yet, but we'll first look at what do we mean by strict dominance, right? So let's consider a simple 2x2 game for, so we have two players and so let's say player one has two strategies. So he can move up or down, and player two has two strategies as well. So he can move left or right. And the payoffs are, let's say, 5 for player one and 4 for player two, and let's say 4 for player one and 3 for player two, and here is 3 and 1, and here is 2 and 2. All right. So let's say player one plays up, right? So if player one plays up and player two plays left, player one gets 5. And if player one to play down, then player gets 3 when player two plays L, right? So clearly up is better than down when player two plays L, right? For player one. And for player one, again, up is better than down when player two plays right, because player one gets 4 with up and only 2 with down. So clearly 4 is better than 2. We're assuming players are trying to maximize their payoffs, right? And they are rational. So in this game, as you can see, strategy up strictly dominates strategy down, right? So that's you have strict dominance in the pure strategy. But there are situations, there are games where strict dominance in pure strategy may not be feasible. So in that case, we can look at the mixed strategies, and if mixed strategy can dominate other strategies, that's also feasible. So let's consider another game. So let me write down. So let's say we have a game again between two players. So here we have this game, And let's say player one has 3 strategies to play the game, all right? And player two has 2 strategies to play the game. So player one has 3 strategies and player two has 2 strategies. So 2 can move left or right, and 1 can move either up, middle, or down. And let's say the payoffs are 4 and 0, and here 2 and 3, and here 0 and 1, and here is 4 and 2, and here is 1 and 2, and 1 and 3. Okay, so these are the payoffs. Now what you see, there is no pure strategy for player one that dominates the other strategies of player one. So that's evident. So let's say you take up, strategy up for player one. So player one's strategy up is better when player two plays L, right? Because player one gets 4. If he plays M, he's gonna get 0. And if he plays down, he's gonna get 1, right? So clearly 4 is better than either 0 or 1. So clearly up dominates middle and down when player 2 plays L. But if player 2 plays R, then what happens? If player 1 plays up, he gets 0, which is inferior to, playing M, where player 1 gets 4, or playing down, where player 1 gets 1. So clearly up does not dominate middle or down. And similarly, you can look at the other 2 strategies of player 1, middle and down. They don't dominate the other strategies either. So there is no strict dominance for player 1 in pure strategy. So then we can look at some mixed strategies. So let's say we are considering a mixed strategy where player 1 chooses up with a probability of half, middle with a probability of half, and down with a probability of 0, right? So this is a mixed strategy for player 1. One, mixed strategy for player 1, sigma 1. So half, half, and 0. So now what happens is the expected payoff of player 1 with this mixed strategy. So let's consider, player 1's mix, payoff, expected payoff with this strategy, mixed strategy sigma 1, given the rival, is player 2, right? So he's playing L, let's say. What would player 1 get here? So if player 2 chooses R, then player 1 will get 4 times half, because that's the probabilities he's going to play up, right? Half plus 0 times half. So he plays the middle with half probability, so he'll get 0. And then plus down, so he'll get 1, but the probability of that is 0. It's playing 0. So therefore, the expected payoff is going to be 4 times 1/2 is 2 plus 0 plus 0. So that's 2. So her expected payoff from playing this mixed strategy, right, when player 2 plays L, this strategy is 2. Clearly, 2, once he plays this strategy, dominates down, right? So this mixed strategy of half probability half, assigning probability half on up and probability half on middle, right, that yields an expected payoff of 2, which is strictly better than 1. So you'll get by playing down, right? So, and then let's consider what if player 2 plays R. So in that case, her expected payoff is going to, so U1 of sigma 1. So this is U1, expected payoff of player 1 once he plays sigma 1, the mixed strategy, 1/2, 1/2, and 0. And player 2 playing R. In that case, still get 0 with probability 1/2, because up gives 0. Middle gives 4, so 4 times 1/2. and then still get 1 with a probability of 0. So 1 times 0. So again, the expected payoff is 2. So this mixed strategy that player 1 has, 1/2, 1/2, and 0, results in expected payoff of 2, no matter what player 2 does. And clearly, that is going to dominate the strategy D for player 1 because he gets 1, no matter what player 2 does. So this is your dominance in the mixed strategy here, right? So, but, there are situations where, strict dominance may not be feasible, even in mixed strategies, right? So then we can resort to mixed strategy or pure strategy, right? So we can always look for what we call as weak dominance. So let's look at the case of weak dominance. So weak dominance. So here, the definition is very similar to the strict dominance with one basic difference. So here, ui of sigma I given s minus I is greater than equal to. So this is the difference. Right? Earlier in the strict dominance case, we had just greater, strictly greater than sign. Here we have greater than equal to sign. So that's the only difference you have from the previous definition here. All right. So now let's consider another game here. So we have two players, 1 and 2, and both of them have 3 strategies. So player 1 can choose to play up, middle, down, up, middle, down, and player 2 can choose to play left, center, and right. Okay, and the payoffs are, let's fill in the payoffs here. So for player, let's start at 2. So let's say 3 and 5 and 5. And then player 1 has 1, 2, 3. And here, say 0, 3, there is 1 and 4. And here is, let's say, 2 and 3. And over here is, let's say, 2 and 2. Here is 3 and 2. And here is 1 and 1. All right. So in this game, let's focus on player 2's strategies here. So let's focus on, so we can clearly see if you're looking across, scanning across columns for player 2, you can eliminate, L right away, because L is dominated by, you can't, do it in that sense. Here, so L, could be dominated by C or R when player 1 chooses up, and it's dominated by C and R both when player chooses middle. But L is not dominated, right, by C or R. There's a tie here, right, between C and L, but R is inferior. So you can say, L is strictly dominated by either C or R. And similarly, let's look at strategies C and R. Here, what happens is when player 1 chooses up, there's a tie between C and R for player 2, because player 2 will end up getting 5 and 5, right? But if player 1 chooses M, then C is better than R, because C results in 4 and for player 2, and R results in only 3. And when player 1 chooses down, then C results in a payoff of 2, and one result, R results in payoff of 1. So clearly, strategy C is as good as strategy R for player 2 here, right? But it's not a strict dominance because there's a tie between C and R when player 1 chooses up. So we can't say that C strictly dominates R, but you can always say that strategy C of player 2 weakly dominates strategy R of player 2, because when player 2 chooses C for any given strategy of player 1, C is as good as with R, right? So C is strictly better off when C plays M and D relative to playing R, right? When C chooses C. So C results in strictly better payoff for player 2 relative to strategy R when player 1 chooses middle or down. But if player 1 chooses up, then C is, C gets equal payoff of 5, right? So clearly, strategy C weakly dominates strategy R for player 2 here.